I will take my role as moderator to ask the first couple of questions, but please, everybody, ask your questions in the chat or just post a little note that you have a question and I'll call on you after that. But I'll ask the first one. So I have a couple. So maybe starting with that end one. So you put up the example of the state-dependent single server queue, and there's actually potentially a very interesting bridge between that and the next talk, which is on speed scaling in queues. So have you thought about the implications of kind of your results for state-dependent service rates in terms of power and energy, since you could view maybe that control policy as trying to modulate the speed in order to have a better power versus performance trade-off? Is that something you've considered yet?
Uh, yeah, so yeah, that's a very interesting question. We have considered something similar in the two-sided queue case, but there the trade-off is in between because these arrival rates are modulated by prices, so there the trade-off is in profit and the performance, the delay performance, and you see a very nice trade-off there that in one of the regimes you get higher profit, one of the regimes you get better delay performance. But yeah, I think it's very interesting. We can see her as well, I think, but we haven't really thought about it in this case.
Perfect. And then one more before I go to the chat. I couldn't tell from the proof, of course, because you just did a high level, but it would be very interesting, from the gig economy perspective to think of this in terms of multiple types of servers and jobs and be able to do that mapping. At the high level that you gave, it seems like maybe there would be potential to extend things in that direction. I'm assuming you've thought about it from your nod right now. Are there obvious hurdles that have to be overcome?
Yeah. That's like the next thing we were thinking about. Yeah, I think another thing that needs to be overcome there. One was state dependent arrival rate, which kind of is overcome using all this, and the other one is the multiple types. I think there'll be a matching policy on top of it, and I think we'll need to show something like CRP, state space collapse, so that it becomes tractable. So probably you use CRP, state space collapse, and then it collapses into a single dimension, and then you kind of use these results to get the distribution for the matching case. But obviously it's not clear if it's going to work, but that's the idea.
So not low-hanging fruit, but interesting direction.
If I may
Yeah,
add,
interesting direction.
we actually already did all of this in another piece of work, but in the context of only the mean queue lengths, not the distribution. So that's where we got started with ride-hailing applications. Then we asked the question about what about distribution, and this is the first piece of work doing the single thing.
Right.
And now combining both of these to get distribution and the multiple type case is open.
Very nice, very nice. And then I see a question in the chat. JK, would you like to unmute and ask yourself?
Thanks. So my question is, I was curious about why you need these two parameters, epsilon and tau, to define your scaling regime, right? You need this one parameter that's the magnitude of the control and the other is the sensitivity of the control. I mean, if you had just one of these, perhaps, would it still be possible to define a meaningful limiting regime?
Definitely. You can just have one, and like you can just have epsilon. You can keep tau equal to a constant, and that will correspond to the regime 1. So tau being constant, epsilon going to 0, that's epsilon tau going to 0. So it will be meaningful, but probably you won't see a phase transition there.
Got it. So if I may, I have one more question. So in the classical so-called one-sided queuing regime, right? You have these different scaling regimes, right? You have the quality driven, the efficiency driven, the QED type regime, and so on. Are there any parallels between these different cases that you have here and the type of different scaling regimes in the so-called one-sided queuing world?
Yeah, I think yeah, we were thinking about it, but I don't have a concrete answer to this.
But I think we can make an analogy with those regimes, but then there is no like formal connection. Maybe that is what we can say at this point. I think we can say that in one regime, one of the things dominates and things like that. So in spirit, it's similar to QED, quality driven and efficiency driven, but it's not identical. The story is like very different.
Great. Thanks.
Perfect. Thank you. That was a very interesting paper and discussion. But let's now move to our next speaker.